Hello dear CMA aspirants from South India. As you all already know, Akash Agarwal Classes has launched for you all 100% English lectures in English for CMA Foundation students giving their examination in December 2025 and onwards. So here I am going to tell you how do you enroll in the batch. You just have to join our WhatsApp community which is given in the link. Fill up the Google form again given in the link and do download our mobile application Akash Agarwal Classes to access the notes. You all know the lectures which we are going to conduct will be 100% covered. There would be no subject which we are not taking care of. So we are going to take care of each and every subject, each and every concept. We are going to take MCQs for you. We are going to provide test papers. We are going to take live mentee sessions as well. Lectures which we are going to take for you all are 100% recorded lectures and not dubbed lectures. And you all know we have exclusive team ready for you all to teach you for your CMA Foundation December 2025 attempt for subject wise as well. And we are uploading the lectures on a weekly basis. All the important links which will be useful to you all are uploaded in the description box. Since we have many students who have cleared CMA examination at all the levels from Akash Agarwal Classes, and to reciprocate the love which we have received from South Indian students, we are here for you all taking lectures 100% in English, so that we can clear your CMA Foundation December 25 attempt together. So keep studying, do watch all the lectures till the end, and do show some love by liking the video, subscribing to the channel, and putting up a word in the comment box. Keep studying. Bye-bye.
So hello my dear students, welcome back to another lecture of our probability. Yeah, this is going to be our second lecture of probability, and students, we have already studied many things in probability, or the basic concepts that are required. We have started the chapter, and yes, let me tell you again, all those students who are new to the channel, Akash Agarwal Classes has launched its exclusive batch for CMA students, which is going to be conducted in totally English. Yeah, you have heard it right. As you all know, Akash Agarwal Classes is the leading institute in CMA Foundation, throughout the CMA course as well as in the CMA final. We are providing lectures in English as well. So yes, do share this news, do share this video with all your friends who want the lectures to be conducted in English and want to see this lecture, are gonna get benefit out of this lecture. You should definitely share this video with all your friends. So yeah, let's come to the topic. And before that, one more thing that I just missed was there is a WhatsApp community. Yeah, there's a WhatsApp community we have created. The link of the community is available in the description box. You can join the link or join that WhatsApp community through that link, because we are going to update many things, many strategy videos, many videos which are going to be conducted in English and which are going to give you benefit for your exams. So yes, do join the WhatsApp community. That is, the link is available in the description box. Okay, so let's come back to our topic. In last lecture, we have studied what? Let's see in last lecture what we have studied. We have studied that the probabilities, chances, probability occurs when we are doing some kind of random experiment. And then we saw multiple random experiments, such as the dice is rolled, a coin is going to be tossed, two coins to be tossed, three coins to be tossed. The formula for coin tossing: 2 dice are rolled, then playing card, we study about 52 playing card, 26 red, 26 black, 15 of them are heart, 15 of them are diamond, 15 are club, and 15 are spade. In those 15 cards, 10 of them are face cards, and the other 3 are what? Other 3 are their other 3 are face cards, and the 10 of them are number cards. Face cards are what? Face cards are king, queen, and jack. All together, there are 4 suits. Including all 4 suits, there are how many face cards? There are 12 face cards total, and there is the number card one is said to be an ace card. For poker hands, there are always 5 cards. You have to remember this 6. Then we studied about the formula, that is combinations formula. In permutation combination, you might have studied, and say we are studying over here, the combinations formula is n factorial upon r factorial into n minus r factorial. and then we saw how to solve it. Then we saw the probabilities formula, favorable outcome upon total outcome. Total outcome is nothing but the all possible outcomes which we said to be sample space. Then we have also seen that the probability, when the probability is 0, the event is not sure, it is an absurd event. When the probability is 1, it is a sure event, the event is 100% going to happen. That is everything we studied. In our previous lecture. Right now, let's go to some examples. Let's see some examples. We have studied dice. We have studied permutations, formula, total cards 52. Let's see your playing cards. There are total 52 cards, 4 suits, diamond, heart, spade, and club. There are total 13 cards in every suit. 4 ace cards, ace card of diamond, ace card of heart, ace card of spade, ace card of club. And there are 4 king cards, 4 queen cards, 4 jack cards. Jack are also said to be knave. The key is going to be silent over here, knave. And there are 4 cards. And apart from that, there are number cards. Each number card, ace card is 4, 2 number card is 4, 5 number card is 4, 10 number card is 4. Face cards, total face cards are 12. Face card including ace. So the face cards, king, queen, jack of all suits and ace of all suits. So 4 into 4, it is going to be 16. Honor card, just like your the thing over here. Face cards including ace is said to be honor cards. Honor card या honor card. Face card including ace is nothing but honor card या owner card. They are 16. Number of poker hands, as I said, you have to keep this in your mind. There are going to be 5 cards. Number of color, there are 2 colors, red and black. 26, diamond, heart, club and spade. Diamond looks something like this, heart looks something like this, spade is this, club is this, and this is going to be your spade card. Now, what is an event? What is an event? Let me give you an example. What is an event? What is an event? Okay, so when I roll a dice, die. Okay. Now, when I'm rolling a dice, what are the possible outcomes? Possible outcomes means sample space. These are possible outcomes. When I'm rolling a dice, 1, 2, 3, 4, 5, 6. These are possible outcomes. Rolling a dice is a random experiment. Rolling a dice is what? Is a random experiment. Sample space is 6. Number of sample space is 6. And now, what is an event? An event is, what is the probability of getting an even number? So, getting an even number is going to be your event. Probability of getting an even number is going to be your event. So this is event. This is going to be your what? Event. Now when we are going to solve, we are going to say let A be the event of getting even number. What all are the even number? 2 is even, 4 is even, 6 is even. So there are total 3 even numbers. Total samples is 6. If you remember, favorable outcomes upon total outcomes. Favorable outcomes are 2, 4 and 6. So 3 favorable outcomes, total outcomes 6, 3 upon 6. Your answer is going to be 1 upon 2. This is what your probability of getting even number. So event is something what you want. And then our formula is going to be favorable outcome upon total outcomes. So event. A coin is being tossed at the random, sample space is head. Let E be the event of getting head. So what we want are favorable outcomes. We want event to happen, and the event is what? Event of getting an head. So it is going to be E. A dice is rolled at a random, getting an odd number is an event. This is a random experiment. Throwing a coin, tossing a coin is a random experiment. Throwing a dice, rolling a dice is a random experiment. But what we want is an event. What we want to happen is an event. What is null event? Null event means a event that is not possible. The event has no sample point is called as a null event. It is denoted by null. If A is a null set, then number of A is 0. Null event. Like when I am when I am tossing I have tossed a single coin. My sample space is head and tail. I want an event A. My event E is I want two heads to occur. I want two heads, but this is not possible because I am tossing a single coin. In single coin, either I'll get a single head or single tail. I'm not going to get two heads at a time. For that, I'll have to toss two coins. So this is not possible. And when it is not possible, it is a null event. Simple or elementary event. The event which cannot be decomposed into further event is called as simple or elementary event. That means there is not going to be any further steps. A coin is tossed. Once, then there may be two simple events, either head or getting tail. There is not going to be anything else. After getting head, there is no further step. It is going to get over there and there itself. Event of getting an head or event of getting a tail is what a simple or a elementary. Composite event. Mixture of two events is going to be composite or compound event. Let's get to an example. Toss two coins. Now, after I toss one single coin, I'll get one outcome. My final outcome is going to depend upon after tossing second coin. So my final outcome is depending upon what? Two events. Two random experiments of tossing two individual coins. So two coin is tossed a coin is tossed twice. A single coin is tossed what? Twice. It is an example of composite or compound event. It can be split into events: head, tail, first coin head, second coin tail, second coin tail, first coin head. Yes, this is a simple event over here. When we are tossing two coins, it is going to be what? Your compound event. You have to keep that thing. Now we are going to see mutually exclusive event, equally likely event. What I will do is I'll write it down everything for you. So let's get over here. Give the heading of types of event. Types of event. Mark it very important because there is going to be a question which are going to be based on your event, and then they are going to ask you some kind of questions. Like we'll see. I'll give you a relay. When this type of question occurs, I'll give you an example. Like this is from a type of element question. So first is going to be mutually exclusive. Mutually exclusive. Mutually exclusive event means there is no intersection. There is no intersection. That means your intersection is 0. What is the intersection now? I am performing two random experiments. I performed one random experiment and then another random experiment. There is no common thing between first and second event. There is no common thing between first event and second event. That is going to be a 0 intersection. Intersection is common things between two events or multiple events. So here there is no common thing. So the intersection over here is 0. So the intersection is 0 over here. Therefore, probability of A union B is equals to probability of A plus probability of B minus probability of A intersection B. This is what? This is our original formula. Right? This is our what? This is our OG formula, original formula. But over here, this intersection is 0. That means probability of A union B in case of exclusive event is going to be only probability of A plus probability of B and not minus A intersection. Now this is number of A, number of A, number of A, this. And when I am going to say probability of A union B, it is going to be probability of A plus probability of B upon probability of S. So I am going to say number of A, number of B upon number of S. So this is going to be your what? Formula for probability of A union B. That means occurrence of both the events. Here the intersection is going to be what? Here the intersection is going to be 0. Intersection is nothing but as I told. See, if you don't know, if you have not studied sets, let me tell you, this is an event A, this is an event B. Sometimes what happens is in event A and event B, there are some common things. So this is your A intersection B. Common things between A and B. So this is what your A intersection B. Sorry, A intersection B. What is going to be your A union B? A union B is going to be all the part. All this part is going to be your A union B. So A union B's formula is what? A plus B. And why are we like subtracting the intersection part? Because what is happening is we are taking this part in A. This part is already included when we are considering A, right? And this part also gets included when we are taking B as well. So what happens is this part, the common part is going to come twice in when we are selecting A as well and when we are selecting B as well. So that center part which is twice comes what? Comes 2 times at the time of A as well and B as well. That's the reason what we do, we subtract it once. So these elements over here come only once. So this is the reason. Okay. Now let's go to the second type of event. Second type of event is exhaustive event. Now what is this exhaustive event? Exhaustive event is going to be when I add probability of A and probability of B, my total is going to be 1. As we know that the probability, when the probability is 1, that means what? That means it is 100% sure, right? So it is going to be full, like the maximum is going to be 1. So here when I add probability of A and when I add probability of B, total I get is 1. Total I get is 1. And also probability of A plus probability of B plus probability of C is 1. When I am talking about 3 events, adding all the 3, I am going to get what? I am going to get 1. Okay, so the third kind of event is equally likely event. Equally likely events. What does this means? Probability of all events are same. That means probability of A is equals to probability of B. Equally likely event. The happening of event A is equally likely of happening of event B. That means the chances of happening A and B are same. They are equal. Next comes independent event. Independent events. So in independent events, I multiply probability of A into probability of B, and then I'm going to get probability of A intersection B. When I multiply probability of A and probability of B, I'll get what? I'll get probability of A intersection B. I'll get probability of A intersection B. So this is your all types that you need to keep in mind. Okay. So this is all everything. That these are four types of events that you need to keep in your mind. Let's go further. We have seen mutually exclusive, equally likely, exhaustive event. Okay. Now let's come to some examples now. A coin is tossed at a random. Find the probability of getting a head. When a coin is going to be tossed, the probability, what is going to be the sample space? The sample space is going to be either head or tail. When a coin is going to be tossed, the sample space is going to be either head or tail. Find the probability of getting a head. So probability of A is going to be favorable outcomes. What do we want? We want head. So what are the chances of head? 1. And what are the total chances? 2. So of getting a head, the chances are option number A, probability of A is 1 upon 2. Probability of A is 1 upon 2. 2 coins are tossed. Now what is going to be the sample space for 2 coins tossed? Head, head. Head, tail. Tail, head. Tail and tail. So what are the total sample space? What are the number of sample space? They are 4. What is the probability of getting head? Probability of getting head is getting head on both coins. So both coins getting head is only 1. So total is 4. The answer is going to be 1 upon 4. Option number B. Simple questions. Right? Then a dice is thrown. All these questions are very easy. That's the reason I'm solving it a bit quicker. I hope the concept is already clear and all the students are being able to solve the question. These are very easier questions. You might have studied it in 10th standard. So there's not going to be a very big deal. So don't start in the comment section commenting like why you're running and something like that and whatnot. So this is very easy question. That's the reason. A dice is thrown at a random. Okay, so a single dice is thrown. Means what is going to be the sample space? 1, 2, 3, 4, 5, and 6. Find probability of getting a face number greater than 4. That means when I roll a dice, I should get what? I should get a number greater than 4. So for number of event, let A be the event. So now there are no need for writing all the steps. Or what were we doing in 10th standard? We used to write all the steps. Let S is equal to the sample space. Then we used to write the sample space. Then the number of sample space. Then we used to write let A be the event of getting a number greater than 4. Then we used to write number of. No need. The solving is only for ourselves because our paper is going to be MCQ based. Even if I write in everything in rough, it is going to be more better for me. It is going to consume my less time and it is going to help me a lot. But I am writing it in detail now for all of you to understand so that you can make the notes. That's the reason. So your favorable event is what? Getting a number greater than 4. So number greater than 4 is what? 5 and 6. So sample space for event A is going to be 5, 6, and therefore number of A is 2. The probability of happening of A is 2 upon 6, and 2 upon 6 is 1 upon 3. Option number B. Hopefully everybody is with me and everybody is writing with me rather than just looking what I am solving. Do solve it with me only. There's no reason to wait for anybody. Just keep on solving with me. Okay. Two dice are thrown. Find the probability of getting same face number on the both dice. So when we roll 2 dice, if you remember the sample space, it is going to be 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. 2, 1, 2, 2, 2, 3, 2, 6. 3, 1, 3, 2, 3, 6. 41, 42, 46, 41, everything. There are total going to be 36 observations. Now I want is, so in that number of S was 36, and now I want event A. So event is going to be 1 1, 2 2, 3 3, 4 4, 5 5, 6 6. So number of A is going to be 6. So probability of A is going to be 6 upon 36. That means 1 upon 6. Option number B again. Very easy, very easy question. Two dice are thrown when the probability that the sum of page number is greater than 8. Okay. So now I'll need my sample space. My sample space is what? 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, 2 1, 2 2, 2 3, 2 4, 2 5, 2 6, 3 1, 3 2, 3 3, 3 4, 3 5, 3 6, 4 1, 4 2, 4 3, 4 4, 4 5, 4 6, 5 1, 5 2, 5 3, 5 4, 5 5, 5 6, 6 1, 6 2, 6 3, 6 4, 6 5, 6 6. So this is going to be your sample space. What are the total number of sample space over here? 36. Now what do we want? The probability of A is going to be favorable outcome upon total outcomes. So total outcomes are 36. Now I want is greater than 8. So greater than 8 is going to be 6 plus 1, 7. 5 plus 2, 7. 6 plus 2, 8. I want greater than 8. That means 9. 5, 6 plus 3 is 9. 4 plus 5 is 9. 4 plus 6 is 10. 5 plus 6, 11. 5 plus 5, 10. 8, 5 plus 4, 9. 5 plus 3 is 8. I want greater than 8. So 6 plus 3 is 9. 10, 11, 12. So how many observations? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 upon 36. So 10 upon 36 can be written as what? 10 upon 36, 2 5s are, and 2 18s are. So it can be written as 5 upon 18. Option number B. 5 upon 18, option number B over it. When I roll 2 dice and I want sum greater than 8, it is going to be 5 upon 18. Very simple, just note it down. Hopefully everyone is with me, all of you are understanding all the concepts. Now let's solve some question for combination. Now we're going to solve what? Some questions for combination. We have already written the formula for combination. What was the formula for combination? If you all remember, what was the formula? N factorial upon R factorial into N minus R factorial. Right? That was the formula. Now let's solve a question. Everybody is going to keep an eye on it. Focus on the particular question that I am solving so that later on you don't face any kind of problem over here. A bag contains 6 red and 4 blue balls. So there are 6 red balls. There are 4 blue balls. So there are 6 red and 4 blue balls. So there are total how many balls? total 10 balls. One ball is going to be drawn randomly. One ball is going to be drawn what? Randomly. Find the probability that the ball is red. So how many total balls? 10 balls. So my probability of A is what? Favorable outcome upon total outcomes. So total balls are 10. I'm going to draw how many balls? Find the probability that the ball is drawn. One ball is drawn. So I'm going to draw 10 ball. So total ball, if you remember NCR, total and what we want. So we want one ball. Total there are 10 balls and we want one ball. So 10C1. And we want is what? We want red ball. So how many red balls are there? So from 6 red balls, I am going to draw one particular. So 6C1. What is the formula for 6C1? 6 factorial upon 6 minus 1 factorial upon 1 factorial. Right? So this is going to be what? 6 into 5 factorial. 1 factorial into 6 into 1. 5 factorial. 5 factorial, 5 factorial cut 6. So the answer is going to be over here 6. And now similarly your answer is going to be 10 over here. So 2 3s are 6, 2 5s are 10. The answer is 3 upon 5. Answer is going to be 3 upon 5. Once we solve 3 upon 5, we get 0.6. Option number A, 0.6. Hello. Yes, dear students, the remaining part of combination, the part in probability of combination, we'll be completing it in the next lecture. So this lecture is going to be a small lecture, a short lecture. So hopefully you would like the content, and hopefully the concept that I have explained have been clear to you all. Let me know in the comment section, like how did you find the lecture? Was it helpful or not? So yeah, do comment, and we'll see you in the next lecture. Bye bye.